Today we will learn about plane figures and solid shapes. We have studied various geometrical shapes like squares, rectangles. All these shapes are flat. That is, they are situated in one plane. Therefore, we call them plane shapes. A plane shape has two dimensions, length and breadth. So, these are called two-dimensional shapes. In short, these are called 2D. We can measure the length and breadth of these geometric shapes. Is this shape also two-dimensional? Think. Let me tell you, we cannot find the length and width of this shape, but we can place it in a big rectangle in such a way that its entire shape is inside the rectangle. Since the rectangle is two-dimensional, we can say that this shape is also two-dimensional. In this way, it is not necessary that the two-dimensional shape is always a polygon. It can be of any shape which is situated in one plane. We can say that square, triangle, circle, pentagon, etc. also are two-dimensional shapes. Now look at this shape. This is a cube. Is it a two-dimensional shape? Think. We see that it has three dimensions: length, breadth and height. Being three measurements or three dimensions, this shape is not situated in one plane, but it occupies space in different planes. Shapes that have three dimensions, such as length, breadth and height, are called solid shapes or three-dimensional shapes. In short, these are also called 3D. In the previous class, we have studied about some geometric shapes. Do you remember? Pause the video and recall it. Some examples are as follows. This is a cube. Dice, Rubik's cube, ice cube, all have cubed shape. This is a cuboid. Objects like matchbox, sweet box, books all have the shape of cuboid. This is a pyramid. In pictures, you must have seen the Egyptian pyramids. This is a prism. You must have seen this type of glass object. When rays of sun fall on this object, we see different colors. This is a prism. This is a sphere. Objects like laddu, ball, football all have shape of the sphere. This is a cylinder. You must have seen this shape in the shapes of pen, bottle, cell battery, etc. This is a cone. Many times you must have eaten ice cream in the cone. On the birthday, you must also be wearing a cone-shaped hat. Can you remember any other objects in which you have seen these shapes? You must find the name of some other objects. Now look at these shapes. Are these also a three-dimensional shape? Think. Let me tell you, here we can see that all these objects are occupying space in more than one plane. So we can say that all these objects are three-dimensional shapes. Look around your surrounding and find out which objects are three-dimensional. Today we have learned about plane figures and solid shapes. In the next video, we will see examples related to this. Today we will see examples related to plane figures and solid shapes. Classify the following figures according to their dimensions and identify the shapes. Here, the shapes shown in first, second, third and fifth figures seems to occupy the space. We see that they have the three dimensions such as length, breadth, and height. So, we can say that these are solid shapes or three-dimensional shapes or 3D shapes. However, the shapes shown in 4th, 6th and 7th figures lie in one plane. They have two dimensions such as length and breadth, and third dimension is absent. Therefore, we can say that these shapes are plane shape or two-dimensional shape or 2D shape. Next example. Following figure is made up of how many 2D shapes? The figure shown here occupies some space. We can say that shape has three dimensions such as length, breadth and height. So, the shown figure is a solid shape or three-dimensional shape, that is 3D shape. This shape is made up of different flat parts. So, we can say that these are two-dimensional shapes or 2D shape. To find out the number of 2D shapes in this figure, we have to count all these 2D shapes. We see that this shape is made up of one rectangular 2D shape and four triangular 2D shapes. That is, this shape is made up of 1 plus 4 is equal to 5 two-dimensional shapes. So today we have seen some examples of plane figures and solid shapes. In the next video, we will see the misconceptions and common mistakes related to this. Today we will see misconceptions and some common mistakes related to plane figures and solid shapes. Misconception 1. The measurements of all the angles of the following figure is 90 degree. Identify the shape. This shape has some length, breadth and height. That is, it has occupied some space. Therefore, the shape is the three-dimensional shape. Some children see that all the faces in the given three-dimensional figure are made up of four sides, so it is a quadrilateral. That's why they think that this is a cube. Here, the children do not notice that all the faces of this shape are not square shape. They answer option 1, which is a wrong answer. All the faces of a cube are square shape. All faces of the given shape are not square shape. So, this shape is not a cube. But its all faces are rectangular. Three-dimensional shape whose all faces are rectangular is called a cuboid, which is option 2. This means that option 2 is the right answer. Misconception 2. Which of the following figure is a two-dimensional shape? Some children understand that only geometric shape like rectangle and circle are two-dimensional shapes. So, they think that figure 3 is not a two-dimensional shape. So, they give option 1 as an answer, but this is a misconception. Some children think that only the shape whose length and breadth can be measured are two-dimensional shapes. They think that only the rectangle's length and breadth can be measured. So, they understand that only figure 1 is a two-dimensional shape. With this misconception, they answer option 2, but this is also the wrong answer. Here, each figure is situated in the one plane. Neither of these shapes occupies any space in more than one plane, nor does it have any third dimension. So, all these shapes are two-dimensional. Hence, option 3 is the correct answer. Mistake 1. Misidentification of the shapes of object in the surrounding. If children are asked the shape of the matchbox, door and ball, then they say that matchbox and door is rectangular and the ball is circular. This is because in their childhood, while identifying shapes, it was said that the matchbox and the door is rectangular and the ball is circular. Remember that the matchbox and the door have 3 dimensions such as length, breadth and height. That is, the matchbox and the door has 3 dimensions. Therefore, these are 3-dimensional shapes which are called cuboid. If we talk about the ball, then we see that it is not situated in one plane. Therefore, it is also a 3-dimensional shape which is called a sphere. Mistake 2. Ignoring definition while identifying the shapes. If we show a rectangle to children and tell them its definition, then many times they remember the shape but ignore the definition. If we show them a rectangle whose orientation is different from the rectangle of their understanding, then they are unable to identify this shape. This is because they do not identify shapes on the basis of definition. According to their understanding, such a shape is a rectangle. The definition of rectangle tells us that a shape whose opposite sides are parallel and equal and all angles are right angles is a rectangle. By definition, we can say that it is a rectangle. Therefore, to identify any shape, it is necessary to know its definition. So today we have seen misconceptions and some common mistakes related to plane figures and solid shapes.
Today we will learn about nets of 3D shapes. Let's understand this with an activity. Take a cardboard. Draw squares of equal measurement on it. You can take the square's arm according to the size of the cardboard. Now, cut the shape and separate it from the cardboard. Now, fold each square to form a 3-dimensional shape like this. From this, you will get a cube. Thus, here we have obtained 3D shape with the help of a structure. A skeleton outline in 2D which, when folded, results in a 3D shape is called a net. Like it is a net of a cube. When you go to the sweet shop to get sweets, the confectioner gives you sweets in a box. Often, the boxes at the sweets shop are cuboid shaped. If you open any such box and level it, you will see its net. You must have worn a birthday cap on your birthday. It is shaped like a cone. If you cut a cone along a point on its oblique surface and along the line going from the vertex, you will get the cone net in this way. You can definitely make a birthday cap for yourself by making this type of net on a flexible cardboard. Which 3-dimensional shape does this net represent? Think. Absolutely right. This net is of a cylinder. We saw that a cube can be made from this net. Now look at this net. All squares are made in it too. If we fold the squares properly, then we will definitely get a cube. In this way, we can make a cube not only from these 2 nets, but also from all these nets. That means we can say that a solid can have different nets. Many a times we also need to know whether the desired solid shape can be made from a given net or not. Let us understand some important things in this context. While determining whether a given net can form the desired solid, we should keep in mind that the desired solid shape and the net shown have the same number of faces. At the same time, it is also important that there is a correspondence between the sizes of the faces and the faces in the net. Then we'll look at the net and think how we will get the desired solid by turning the net. Look at this net as an example. Can we make a pyramid from this net? Think about it. Let us tell you, there are a total of 5 faces in this net, in which there is one square and the remaining 4 faces are triangular. Together, we also see that there is a triangle on each side of the square. Now we can imagine that if we fold these faces in this way, then we will definitely get a pyramid. In this way, we can find that the given net is of a pyramid itself. We will see more examples related to this in the next video. Today we learned about nets of 3D shapes. You will see some examples related to this in the next video. Today we will see some examples related to net of 3D shapes. Each side of the solid shown below is of 3 cm. Draw the net of the solid. Net is a skeleton outline or framework made in 2D which, when folded, results in a 3D shape. Let us draw the net of the solid shape shown. The solid shape shown is a triangular pyramid. It has a total of 4 faces, all triangular. There is a triangle on each of the 3 sides of the triangular base. To draw a net, we will first draw a triangular base with all sides equal. Now, we will draw an equilateral triangle on one side of this triangle whose side is equal to the side of the base. Similarly, we will draw the triangle of the measure of the base on the remaining 2 sides. In this way, we have drawn the net for the triangular pyramid. Example 2. The lengths of all the rectangles shown in the following nets are 7 cm and width 4 cm, and all the triangles shown are equilateral triangles whose sides measure 4 cm. Find out which nets can be used to construct a triangular prism. We know that a triangular prism has 2 triangular faces as a prism base and 3 rectangular side faces. The 3 nets shown here have 2 triangles and 3 rectangle-shaped flat surface. Let's talk about the figure first. For convenience, we will name various nets. We will fold the triangle PED along the line segment DE in such a way that it is perpendicular to the rectangle DEFC. Similarly, we will be folding triangle QCF along the line segment CF in such a way that it is perpendicular to the rectangle DEFC. Now, we will fold the rectangle ABCD along the side CD such that its side AD is attached to arm PD of triangle PED and the side BC is to be attached to arm QC of triangle QCF. Similarly, we will fold the rectangle EFGH along the side of EF in such a way that its side EH is attached to arm PE of triangle PED and the side FG is attached to the arm QF of triangle QCF. In this way, we will get a triangular prism. Similarly, if we fold the second shape, in this case also we will get a triangular prism. Now draw the third shape on a cardboard. Cut it out of the cardboard and fold it to make a triangular prism. You will be able to know that in this case you will not get a triangular prism. Therefore, we can say that only the nets shown in the first and second figure can be used to make a triangular prism. Can you explain why? Think. Let us tell you. In a triangular prism, both triangles are on the opposite sides, while both the triangles are adjacent in the net shown in the third figure. Similarly, both triangles of a triangular prism have no vertices common, while the triangles in the figure shown have a vertex common. Therefore, in any way, a triangular prism cannot be formed using third net. Example 3. The nets shown represent which solid shapes? Let's talk about the first figure. If we rotate one of its straight sides to the other straight side, the curved part takes the form of a circle. By folding the circular shaped plate, we cover the open area. This gives us the shape of a cone. Let's talk about another shape. We will fold the rectangle in a circular form towards the width and cover the open parts with circular shaped plates. From this, we will get a cylinder. Now, you yourself find out which three-dimensional shape will be obtained from the net shown in the third figure. So today, we saw some examples related to the nets of 3D shapes. In the next video, we will clear up some misconceptions. Today we will see the misconception and common error related to the nets of 3D shapes. Misconception: from which of the nets shown below can a cube be formed? Some children are unable to visualize which solid shape will be formed by looking at the net. They are unable to answer the given question. To overcome this problem, one should try to make a three-dimensional shape by drawing and cutting the net on paper or cardboard. While doing this, which face of the net is being arranged in a three-dimensional shape, care should be taken. The first net is often used in books to teach the cube net. And while teaching, it creates the misconception in children that a cube can be created only with this net. So they give option 1 as answer, which is a wrong answer.
Some children only see that there are 6 square faces in each net. Since a cube also has 6 faces, they think that the cube can be formed from the 3 nets shown.
Here, they ignore imagining the 3D shape from the net and give option 2 as answer. But this is also an incorrect answer.
Here there are 6 square faces
in each net. But if we imagine only net A and net B can build cube. If we talk about net C, then these 2 faces come on top of each other and the space of one face remains empty. Therefore, a cube cannot be formed from net C. That is, option 3 is the correct answer. Common error. If some children are given a 3-dimensional shape and are asked to draw a net, they cannot draw a net. Some children are unable to imagine which net is correct for the 3-dimensional shape shown. Therefore, they are unable to answer the given question. If we cut the shape along the lines shown, we will get this type of net.
Similarly, we cut it along these edges.
Then we will get this type of net. Now, think yourself how to cut this shape that we will get this kind of net. The figure shown is a cuboid. To draw its net, we can consider any one rectangle as the base.
After identifying the faces on all of its 4 sides,
you can draw them on the 4 sides of the base in the net.
Then the net can be completed by placing the face opposite to the base.
It is not necessary that a solid has only one net. Rather, the nets may also vary. Just like a cuboid can have
different nets.
Stop the video and imagine how they will form a cuboid. Today, we saw the misconception and common error related to the nets of 3D shapes. Today we will learn drawing solid shapes on a flat surface. Two figures are shown here.
Can you tell which shape is 2-dimensional and which is 3-dimensional?
Think. Just right. Here, this shape is 2-dimensional and this is 3-dimensional. Here, both the figures are drawn on the same flat surface. Yet, we can easily tell which shapes are 2-dimensional and which are 3-dimensional. Can you explain why? Think. The reason is the art of drawing them. When a solid shape is shown on a flat surface,
the faces drawn are slightly distorted, which shows the shape as a 3D figure. In this way, we can draw any 3-dimensional figure on a 2-dimensional plane, like on a paper. We call this the 2D representation of a 3D solid figure.
Would you like to know how it is done? In this video, we will learn two techniques with the help of which we can make a 2D shape representation of a 3D solid figure. One of these techniques is oblique sketch and the other technique is isometric sketch. Let us first understand what is the difference between them. Here the cube with 4 cm edge is drawn with both these techniques in oblique sketch and isometric sketch. But there is some difference between the two. Can you tell what is that difference? Think. Exactly. The length of sides drawn in the three-dimensional shape by the technique of oblique sketch are not in same proportion, but we still know important information about solid shape. As here, all the three edges seem equal, but in reality, their lengths are not in same proportion. In the picture drawn using the isometric sketch, we see that the length of sides are kept in same proportion. For example, here the lengths of three edges are proportional. A proportionate drawing is drawn on isometric dot sheet. Now, let's learn how to draw them. Suppose we have to draw an oblique sketch of the cube by taking length of the edge as 4 units. For this, we will use a square paper. Step 1.
First of all, we will draw the front face of the cube as a square of side 4 units on the squared paper.
Step 2.
Now we will draw the face opposite to the front face of the cube.
We will draw this face in such a way that its measurement is equal to the front square face, but it is slightly slipped compared to the front square face. Step 3. After this, we will join the corresponding corners of the two squared faces. Step 4. Now, we will show the hidden edges with a dotted line. This is a convention that we follow.
Thus, we have drawn an oblique sketch of a cube of dimensions 4 by 4 by 4 units.
Now, let us draw the isometric sketch of this. We use dotted isometric sheets to draw isometric sketch. With the help of this sheet, we will draw isometric sketch. Step 1. First of all, we will draw a square of 4 by 4 unit of edges to show the front face. Step 2. Draw 4 line segments of 4 unit length from the 4 corners of the square in this way. Step 3.
Now we will join the end points of the line segments in such a way that we get the back face of the figure exactly the same as its front face.
Step 4. Now we will show the hidden edges with a dotted line.
In this way, we have drawn a proportionate 2D representation of the cube.
We will get to know it better in the next video. Today we learned how to draw solid shapes on a flat surface. We will see some examples related to them in the next video. Today we will see
examples of drawing solids on a flat surface.
Draw the isometric sketch of the cuboid shown below. If the measurements of the 3D shape shown on the paper are proportional, then such a picture is called an isometric figure.
Now we will draw an isometric sketch
according to the given measurements.
We will take an isometric dots sheet to draw an isometric sketch.
Step 1. First of all, we will draw a rectangle of 5 unit length and 4 unit width
On the isometric dot sheet.
Step 2. Draw 4 line segments of 3 units length from the 4 corners of the rectangle in this way.
With the dotted lines, we show the hidden edges.
Step 3.
Now we will join the endpoints of the line segments in this way so that we get the back part of the figure exactly the same as the rectangular face in the front.
Step 4.
In this way, we have drawn an isometric sketch for the given measurements. We can also draw isometric sketches in different ways. Let's draw the isometric sketch of this cuboid in different ways.
Step 1. First, we will
Draw a rectangle of 4 units length and 3 units width on the isometric dot sheet.
Step 2. Draw 4 line segments of 5 units in length from the 4 corners of the rectangle in this way. Step 3.
Now we will join the endpoints of the line segments in this way so that we get the back part of the figure exactly the same as the rectangular face in the front.
Step 4.
In this way, we have drawn an isometric sketch for the given measurements.
Next example.
Draw the isometric sketch of a cuboid obtained by placing 3 cubes of edge 3 units adjacent to each other as shown in the figure. The 3 cuboids of edges 3 units are placed adjacent to each other in such a way that one face of one cube is adjacent to the one face of the second cube as shown.
To draw the cuboid, first we will draw a cube. Step 1. First, we will draw a square of measurement of 3 units
on the isometric dot sheet. This square represents the front face of the cube.
Step 2. We know that all the edges of the cube are equal. Therefore, we will now draw 4 line segments of length 3 units each from the 4 corners of the square. Step 3.
Now, we will connect each corner with the corresponding corner with an appropriate line segment. This square represents the face opposite to the front face of the cube.
Now we have created
An isometric sketch
of the cube. Step 4.
Now we will keep the right face of the first cube and the left face of the second cube in common, and then we'll again draw a cube of 3 units.
Step 5.
Similarly, we will keep the right face of the second cube and the left face of the third cube in common, and will again draw a cube of 3 units. In this way, we have created an isometric sketch of cuboid.
Next example, draw the oblique sketch from the isometric sketch shown. We will use square paper to draw oblique pictures.
Step 1. First of all, we will draw the front face of the square paper. We will do this as follows. Step 2. Now we will draw the opposite face to the front face. We will draw this face in such a way that its size is equal to the front face, but it is slightly shifted as compared to the front face.
Step 3. After this, we will connect the corresponding corners of the two faces. Step 4. Now we will show the hidden edges with a dotted line.
Here we have drawn the oblique sketch from the isometric sketch shown.
So today we saw
examples of drawing solids on a flat surface. In the next video, we will see some misconceptions related to them.
Today we will learn about the different methods of viewing parts of a solid. There are many solids around us, such as boxes, ice cream cones, ball, pyramids, etc. These solids are made from different parts according to the size and shape. For example, a cuboid can be made with many rectangular pages. Today, we will discuss the methods with which we can see different parts of a solid. A fun way to see parts of an object is to cut it. Let us understand this with an activity. Take a cylindrical shaped vegetable such as a cucumber or gourd. Use a knife to cut it. For this activity, you can also make a model of clay shaped like a cylinder. Take one of these objects and cut it vertically. You can carefully slice it thin. Here, each piece is circular. We can say that a cylinder is made up of many circular faces that are placed on the same axis. We call this circular panel a cross-section of the cylinder. If the section is not vertical, then we will get different size panel. You can cut different sizes and draw rough shapes of transverse cuts. Another method of looking at different parts of a solid is to see a 2D shadow of a 3D shaped solid. Let us also understand this with a fun activity. For this, you will need a source of light, a screen, and some solid shapes such as cube, cuboid, sphere, cylinder, pyramid. Now you can take a cube and place it in front of the screen. Focus light on it right from the front. You will get its shadow on the screen. Can you tell if the shadow is 2D or 3D? Think. Since the shadow occupies only one plane, we can say that the shadow has 2 dimensions. That is, it is a 2D shape. When we look carefully, we see that it is a square shadow. Similarly, if we place the screen down and place the cube as shown above the screen, and even after light is focused from top, we will get a square shadow. Now look at the figure shown. Here from the front of a cone, light is focused. Can you tell what is the shape of the shadow formed in such a situation? Think. Exactly. This will create a triangular shaped shadow on the screen. In the same way, if the light is focused on the cone from the side direction, then again a triangular shaped shadow will be formed on the screen. Similarly, if a light is placed just above the cone and the screen is placed below, a circular shaped shadow is obtained on the screen. In the same way, you practice the shadow of different objects and draw rough shapes in your notebook. The third method of looking at different parts of solids is to look at them from certain angle. For that, we view the solid from the front or from the side, that is, laterally or from the top. Then we draw the shape of visible scenes. Like, look at this figure. When viewed from the front, we get the front view in this way. Similarly, when we look sideways, we get side view in this way. And when viewed from above, we get the top view in this way. We can also draw all 3 views from the shapes made of cubes. For this solid, the front view, side view, and top view can be drawn in this way. So today we have learned about different methods of viewing parts of a solid. In the next video, We will see some examples related to these. Today we will see examples related to different methods of viewing parts of a solid. Which cross-section will be obtained if the square pyramid shown below is cut vertically away from the top? When we cut a three-dimensional shape along one direction, the face we get from it is called a cross-section of that three-dimensional shape. If we cut the square pyramid vertically from the top, then this will give us a trapezium-shaped face, that is, we get the trapezium-shaped cross-section of the square pyramid. Next example. A light source was placed in the front of three-dimensional shape. This gave a circular shadow. But when the side light was cast on the three-dimensional shape, a rectangular shadow was obtained. Similarly, a rectangular shadow was also obtained when light was from top. Identify the three-dimensional shape. When a light source is placed in front of a three-dimensional shape, we get a shadow. The received shadow is in a plane. That is, the obtained shadow is a 2D shape. A circular shadow is obtained by highlighting the three-dimensional shape from the front. This is possible only when three-dimensional shape can be a sphere or a cylinder or a cone. A rectangular shadow is obtained when this figure is lighted from a side. If we focus side light on a sphere, cylinder or cone, only the shape of cylinder forms a rectangular shadow. Therefore, we can say that cylinder is mentioned in the example. We can verify this from the third position. The third condition tells us that even when the three-dimensional shape is lighted from above, a rectangular shadow is obtained, which is true with respect to cylinder. Next example, find the front view, side view and top view of the solid shown. When we see a three-dimensional shape from the front, we get a front view. With this understanding, we can draw the front view of the given figure in this way. When we look at the three-dimensional shape from a side, we get a side view in this way. We can draw side view of the given figure in this way. Similarly, when viewed from the top, we can draw the top view of the given figure in this way. All three views are similar here. So today we have seen examples related to different methods of viewing parts of a solid. We will see some mistakes related to them in the next video. Today we will learn some mistakes related to different methods of viewing parts of a solid. Mistake 1. If children are asked to draw a figure of solids as shown below, they again draw 3D shape instead of drawing the figure in 2D. Keep in mind that when we draw figure, they are in 2D shape and not in 3D. Therefore, we can thus draw front view, side view and top view. Mistake 2. While drawing the front view, children draw only the front face of the object. If children are asked to make front view of the shape shown, then they take into consideration only the most visible cubes when making the 2D figure. They ignore the cube that appears behind. This gives them such a front view, which is a misunderstanding. Figure as we see from the front must come to the front view of the shape. In front view of the shape, front part and back part should be considered in the front view. As seen here, 4 cubes are visible in the front view in the shape shown. So, while creating the front view, we should create 4 squares like this. Keeping this in mind, we can draw the front view of the given object in this way. Mistake 3. Ignoring orientation of object. Children do not understand the orientation of the shape shown. For this reason, they make the above view accidentally upside down. If children are asked to draw a figure, the top view above the shape shown, then they make this type of figure. In this, we can see that all the squares have been taken into consideration. But this view will be obtained by looking at the object from below and not from above. In this way, children often draw exactly the opposite shape of the figure, which is wrong. The top view of the shape shown is correct in this way and not in this way. Here is the top view of the shape shown. It should have 3 squares up and 1 square down. So today we have learned some mistakes related to different methods of viewing parts of a solid.